In this video, we are going to see few MCQ questions asked in IB past paper. First question is about what initial rate of reaction can be determined from the graph. They have given the graph. From the graph, we should have to find out the initial rate of the reaction. So they have given a hint, initial rate of the reaction. So time t is equal to 0. What would be the rate of the reaction? So you just have to find out a slope which is y2 minus y1 divided by x2 minus x1. So draw a tangent on the lines that they have given. So the 2 points on the y-axis are 1.6 minus 1.2 and the 2 points on the x-axis are x2 minus x1, which is nothing but 5 minus 0, 4 minus 0. So the answer would be 0.4 divided by 4, which is 1 by 10, equal to 0.1. So the option A, which is 0.1 mole per decimeter cube per second is the correct answer. So if initial rate of the reaction is asked based on the graph, you just have to find out the slope at time is equal to 0, right? So the next question is about bond strength based on the values given. The hint here is bond length and bond strength are inversely related. So they have given the bond length. Based on that, you are supposed to find out the bond strength. Of these three values, 1.38 CF, which is having the lowest bond length, obviously it should have the highest bond strength. Based on that idea, B and C would be the right option. Second, obviously second lowest bond length is CC. So option C is the right answer, CCl, which is the least bond strength because of having longest bond length. Next question, this is about rate of the reaction. This is again a rate equation. What rate equation can be inferred from the data? So rate equation, you just have to know about the order of the reaction, right? So they have given the concentrations of x2 and y2 and the rate of the reaction. From that rate, you just have to find out the rate equation. Here, when you keep y2 constant, on doubling the concentration of x2, the rate increases by 4 times. So x2 doubles, rate increases 4 times, right? Whereas y2 doubles, keeping x2 constant, the rate does not change. So y2 is independent of the concentration because the rate doesn't change when you double the concentration of y2. So the option C is the right answer. Next question, this question is about activation energy of a reaction can be obtained from rate constant and the absolute temperature. Which graph of these quantities produce a straight line? This is a straightforward Arrhenius equation. So ln K against 1 by T is the right answer. Next question, the question is about equal volumes of 0.1 molar weak acid and strong acid are titrated with 0.1 molar NaOH solution. Which of these is the same for two acids, right? So weak acid and strong acid, obviously they have different pH value. When they are mixed, titrated, heat evolved would be greater for the strong acid and strong base. Conductivity depends on number of ions. That would also be depend on the strong acid is completely dissociated, giving larger number of ions. So the volume is the only option which depends on the concentration, which is molarity. Both of them are having 0.1 molar. So volume of NaOH needed for the complete neutralization would be same for strong and weak acid. Next question, the question is about buffer solution. Which solution will form a buffer when mixed? Buffer solution is formed by weak acid and its conjugate base or weak base and its conjugate acid. So here all of the first option is equal volume of strong acid and strong base completely neutralized, so it is not forming a buffer solution. All the three options are the combination of weak acid and strong base. So which would be the buffer solution, which will exactly form a buffer solution based on the volume of acid and base mixed. So in the first option 50 ml of acetic acid and 50 ml of NaOH is mixed, obviously CH3COO Na completely neutralized forming CH3COO Na. In the second option more amount of NaOH is there, so complete neutralization of acid and base will remains in a basic solution consisting of salt CH3COO Na plus NaOH, excess of NaOH. Whereas in the case of last option, where it could be 100 ml of acid and 50 ml of base, when they mix together you are getting CH3COO Na plus some amount of acid. This is exactly the buffer solution. So buffer solution would be formed by excess of acid and a fixed amount of base. So option D is the right answer. Next question, the question is about standard electrode potentials. So they have given the potential value, electrode potential value for 3 off cells, chromium 3 plus 2, chromium 2 plus, chromium 3 plus 2 chromium and chromium 2 plus 2 chromium. So the idea is they have given the hint which is electrode potential value. Higher the electrode potential, more it gets reduced or it oxidizes the other species. So comparing the options given are chromium 3 plus can oxidize 2 plus but not chromium. It can oxidize chromium but not chromium 2 plus. It can oxidize 2 plus and Cr. It can oxidize Cr and reduce Cr2 plus. So all these options are based on chromium 3 plus. So chromium 3 plus can oxidize to chromium 2 plus or chromium can be decided by knowing the electrode potential value, right? So chromium 3 plus to chromium 2 plus, the potential value is 0.407, whereas 2 plus 2 chromium, right, this electrode potential value is 0.914. So by comparing the electrode potential value, it is clearly seen that chromium 3 plus is having a higher positive potential compared to 0.914, minus 0.914 and minus 0.407. Obviously the higher value is minus 0.407, which is able to reduce and it can oxidize chromium 2 plus. So chromium 3 plus can oxidize chromium 2 plus. And in the same way you just try to do it for chromium. For that it requires chromium 3 plus 3 electron gives chromium, which is minus 0.744, whereas chromium to chromium 3 plus you just have to flip the potential and changing into chromium 3 plus 3 electron, right? Chromium gives 3 electron, right? The value is 0.744, so plus 0.744. you just have to flip the potential for this one. Since it is given as the two values are given, chromium 3 plus to chromium, the oxidation potential you just have to find out. So of these two values 0.744 would be greater, so chromium 3 plus cannot oxidize chromium. So option 1 is the right answer. So for this one you just have to straightforwardly comparing the electrode potential value. For the first case 3 plus to 2 plus, you can directly compare the potential value because both of them are given in the reduction potential. Whereas in the case of chromium, it is given as oxidation potential, so it has to be flipped, chromium to chromium 3 plus, right? So it has to be flipped, so the value would be plus 0.744, which is greater than the chromium 3 plus, so it cannot oxidize, chromium 3 plus cannot oxidize chromium. So next question, which are isomers of C5H12? So just find out how many compounds are having the same number of carbon atom, which is 1, 2, 3, 4, 5. Option 1 is 5 and option 2 is also 5 carbon atom, whereas the option 3 is 1, 2, 3, 4, 5, 6, 6th carbon atom. So option 1 and 2, which is nothing but A, is the right option. Last question, which is about the information that you are getting through using different spectroscopic technique. So mass spectroscopy, the name itself indicates that you can find out the mass from the mass spectrometry. So the option would be A or B. Next, IR spectroscopy. IR spectroscopy tells you about the functional group present in the molecule. And proton NMR spectroscopy, it will explain you about the groups present in which position. The hydroxyl group is on the second rather than on the fourth carbon. To which carbon atom the particular hydrogen atom is present can be identified from the proton NMR spectroscopy. Thank you.